Okay, so this is section 7.1, part 2, and we're still dealing with the area between curves. If you remember, we talked about area was equal to the integral between the 2 points where they intersected of the top function, if you're dealing with respect to x, and it would be the right function if you're dealing with y. This would be for x, and this would be, if you're doing dx, this would be doing dy. Minus the bottom, and this would be the right function minus the left. All right. So, and on the first one, you are pretty much giving it to you. On this one, you're just going to be given the equations. So the first step you do is you graph your functions. And at least these are the steps I do them in, and have been doing them in for several decades. And then you figure out if f is a function of x or y. You need to know that to figure out which one you're going to deal with, okay? Number 2, then you identify either top, bottom, or right, left functions. So you know which one goes where. Then the third thing you're going to need to do is find points of intersection. And to do this, you're going to set your two functions equal to each other and solve for x or y, depending upon which one you're doing. Okay, step number 4, once we've got all of this, we've got our intersection, we come back up. Now, we do some calculus. So you integrate them puppies. And step number 5. Do a lot of algebra and arithmetic to get your answer. And then step number 6, die of boredom. Because you obviously have 820 million more of these to do. Okay, so I'm going to work through an example of this. Our f of x was x squared plus 2x plus 1, and my g of x was 3x plus 3. So I want to graph these guys. You'll probably do this on your calculator, but you can also do this on Grapher. So my y, first one was x squared plus 2x plus 1. So there's our parabola. And then we had another one which was y equals to 3x plus 3. All right, and I'm going to want to zoom out. Okay, so there we go. This was F, this was G, and here are going to be my points of intersection. So what I'm going to have then is I'm dealing with G minus F, because G is on top. Okay, so we got that. So I come down here and my G is on top. So this is step 2. Step number 3, I'm going to solve these things. G on top, F is bottom, and I'm going to be integrating with respect to x. So now I'm going to set them equal x squared plus 2x plus 1 equals 3x plus 3. Subtract 3x, subtract 3. I'm going to end up with x squared minus x minus 2 is 0. This factors to x minus 2, x plus 1, or x equals negative 1, that is my A, and x equals 2 is my B. So we've got that now. We've got steps 1 through 3. So now we're going to go on and go to step number 4, which is integrating them puppies. So I'm going to have the integral from negative 1 to 2 of 3x plus 3 minus x squared minus 2x minus 1 dx. And I do each one. This is going to give me 3 halves x squared, evaluate from negative 1 to 2. No, wait. I want to combine some terms before I do this. So I'm going to combine my 3x and 2x. So that's going to give me an integral from negative 1 to 2 of x. And I combine my negative 3 of 1 minus 4 minus x squared. And this makes it a little bit easier. If you can go ahead and simplify this out, it gives you less terms to do. And now I integrate, so this is going to give me x squared over 2, evaluated from negative 1 to 2, minus 4x, evaluated from negative 1 to 2, minus 1/3 x cubed, evaluated from negative 1 to 2. And then I come back in and I plug my numbers in. So I'm going to have 2 squared, which is 4 over 2, minus negative 1 squared is 1, minus 1/2, and then minus 4 times 2, minus 4 times the negative 1 is going to make a plus 4, and then that's going to be minus 1/3 of 2 squared is 9, so 9 over 3, 9/3, minus negative 1 cubed is a plus 1, so plus 1/3. And when I add all these up, 4 halves minus 1 half is going to give me 3 halves. A mistake somewhere or other. Oh, this should be a plus. No, that's right. Should be a minus 2x. So I'm right, okay. And then minus 8, that's going to give me 12. Minus 8/3. And you put that in your calculator and you get your number for that. And that's our step 5. And then step 6, of course, we need to do, which is line 4. All right, so remember and review the following. Because this is going to come up in this assignment. First thing is trapezoidal rule. And Simpson's rule. Then the second thing is equation of tangent line at a point, which if you remember was y minus y1 is your derivative, your slope, times x minus x1. And you're going to want this in the form of y equals. It's going to be y equals dy dx, x minus x1 plus y1. And that's the derivative. And the derivative here is evaluated at the point that they give you. And that's the point they give you is x1 and y1. And that should get you through this next homework assignment. The skills are very similar.